Okay, let's take a look at problem 2. It says, using a linear inequality, the map shows the number of tickets needed for small or large rides at the fair. You do not want to spend more than $15 on tickets. How many small or large rides can you ride? So you can buy 60 tickets with $15. All right, so we'll say X is the number of small rides and Y is the number of large rides. I don't see 60 tickets here. Let me make sure I rate it one more time. The map shows the number of tickets needed. Oh, here they are. The map shows the number of tickets needed for small or large rides at the fair. You do not want to spend more than $15. So tickets are 25 cents, small rides are 3 cents, large rides are 15. And so they calculated that 60 tickets will get you 15. Well, you can buy 60 tickets for $15. So if we say X is equal to the number of small rides and Y is equal to the number of large rides, we know that the large rides we have 3 tickets for, and the small rides we need 5 tickets for. And it has to be, we don't want to spend any more than $15, so it has to be less than or equal to 60. So we can graph it at our free graphing calculator at www.desmos.com, and we get 3x plus 5y is less than or equal to 60. And we need to zoom out to see it better. And we have our 2 intercepts at 12 and 20, and I believe this is what they had as well. So the intercepts are the boundary lines, and so x equals 20 and y equals 12 are our 2 intercepts. Step 2, after we find those intercepts, the region above the boundary line represents the combination of rides that require more than 60 tickets. You purchase a finite number of 60 tickets, so you will not be able to go on an infinite number of rides. Shade the region below the boundary. So here is the region. We already did that part. This is the region. And so this is actually the section because I can't do less than 0. So I can't. On the book it shows us that this is actually the section that we can do. Right? And so here I'll try to highlight it again with my lighter here. So here is our actual section. I can put it here. X is greater than or equal to 0, and Y is greater than or equal to 0. And so it's this section where all of them are highlighted, if that helps out better. All right. So all the points with whole number coordinates in the shaded region represent possible combinations. So these are the possible combinations that we can have. We can have 8 tickets. We can buy 8 tickets. And what is this? 6. So we can buy 8 large, 6 small. We can get 10 small and 6 large. Those are the different combinations that we can do. Okay. So now let's look at guided 2. So suppose you decide to spend no more than $30 for tickets. What are the possible combinations of small rides and large rides you can ride now? Use a graph to find your answer. So it's the exact same thing except for 60, I'm going to have 30. Okay, and so that changes it a little bit. I'm going to get rid of this because I don't think it really helps that much. Oops. I'm going to zoom in just a little bit so I can see it a little bit better. And so again, my y-intercept is 2 and my x-intercept is 10. I'm sorry, not 2. This is a 6. 6 and 10. And so this is the area again. So these are my boundary lines. I can't go in the negative direction. So this is the only section that I can have. And so these are all the possible combinations that I can have. I can buy 5 tickets. And this is 1, 2, 3. 5 small, 3 large. I can buy, we don't want half numbers. Let's see. I can buy 10 all small, or I can buy 6 all large. I I can buy, looks like those are the only ones that I can see that are whole numbers. Let's see, we'll put our graph. Let's edit by adding. Oops. It won't let me. No, it won't let me add a table. But looks like the only whole number amounts that I can have are 3 and 5, 10 and 0, and 0 and 6. And those are the only whole number amounts that I can have for that one. Alright. Why did the graph of the solution of probability only include quadrant 1? Because we can only deal with positive values. That's why. We can't have negative amounts of tickets. And we can't ride negative amounts of rides. So that's the right reason why we can only deal with quadrant 1. I hope this helps.